this the inquiry maybe a little step further is you can do a show grid, which we're going to do. And the other thing is you can do a projector mode. And a projector mode does just allow it so that on their screen it does get bigger. I don't really use the projector mode much, but the grid is definitely something you might want to use. So let's kind of go back to what we talked about earlier. And maybe I am doing line segments, okay? And I segment here. And so when I'm looking at this, and maybe just for sake of the graph, I want to have them color-coded, just so we can talk about the orange line and the blue line. And according to where you're starting, this would be a really good one to start off and talk about segment addition. So you could say, okay, how long is the orange line? Well, it's 4. How long is the blue line? Well, it's 2. And so you could even talk about labeling. Now, one of the things that I have not found, and maybe that is just me, but is on some of this is putting actual ABCs on here. So I can put 4, and I just hit this label key, and it's on the orange. And then if I go to the blue here, whoops, sorry, I clicked the wrong blue all the time. If I click blue here, and again I click label, it's going to tell me how long it is. So that might be one we might look at. And so, of course, you could do it several different ways. You could do the entire segment and, you know, and say, okay, well, if I have, or maybe I want to do a color coding, I'm going to take off the label and I'm going to do green for that one. And so, you know, and maybe that's not, you know, something that I can move very well. I can show them, but you can move it and you're like, okay, look here. Let's say that, and I'm going to move that off. But so if that one is 2, what would the orange one, you know, what would be the green one? What would be the orange one? You can decide whatever. Okay. So what I want to say is you can use, and again, make it an inquiry lab, make it talking about segment addition. Now, while we're doing this, you could also look at, okay, these are in a straight line. So you've got 4 plus 2 is 6, which makes us the entire line. Now we could start, if you wanted to, even do what we just did here and pull this up. And maybe even if you don't have full measurements, but I could probably come over and put a label again here. Let's put a label. There we go. Okay, so again, there is my segment. Look how that works. And then maybe I again want to start pulling this down or up or whichever way and start talking to them again. Okay, well, let's look, because I did have the orange plus the blue equal the green. Now orange plus blue does what to the green? Okay, and you could say, okay, well, what did we make? We made not now our segment, now we have us a triangle. And so now it looks like orange plus blue is greater than. Well, let's keep trying. Let's do another. Let's move it over here. Orange plus blue is still greater. Oh, okay, let's go up here. Orange plus blue is still greater. So maybe we could go into assuming, okay, as our hypothesis, that maybe the orange plus the blue will always be greater than the green in order for us to make us a triangle. But equal if it is just collinear. So see, again, there's your inquiry type tab that you're working with here. Okay, then you could also talk about, okay, let's go back to our one that we have here. I think again, I'm a little off. Okay, and you could even talk about, okay, what happens if, okay, so one activity that I like doing with the kids, and I'm going to show it to you, and I found out that it's a little bit, I do it a little bit different when I do it on the Desmos versus if I was doing it in a piece of paper. But what I'm going to do is I'm simply going to draw, or have the students draw for me, a 30-degree angle. Now to do that, I'm again going to use my angle to compass, and let's get 30. That makes it really, let me come out here. Very touchy. There we go. Okay, so there's 30, and then I'm going to just draw my angle. Okay. And I want this to be a right angle. So I may have to adjust here just a little. Anyway, I'll just go ahead and stop with that. You got the idea, but make it a right angle. It does work better. Be sure the kid's in a right angle. And so here's what I'm going to do. I'm going to click on, and here's one thing that I keep doing wrong. You got to hit that arrow key every time. There's my 30. And then I'm going to click on the segment. Here, it keeps, there we go. And I'm going to go green, and I'm going to tell it to label it. And I'm going to go to this one, and I'm going to go red, and I'm going to tell it to label it. And then let's see here, it keeps wanting to go to the angle. Let's see if I can get it. Well, that one's already down here, so we know it's 2. Okay, so that'll work. And so what I have the kids do is make a table, A, B, C. And I call it, I get specific about my A, B, and C because of how I want it to be, but it's according to what you're doing. So we've got A, B, and C. I really wish I could put a, there we go. Oh, awesome. Okay, and so you can do several different things with this, assuming that, see if that's better. Okay, looks better like a right angle. So here's what you're going to do with this, and you can do multiple different things. One, have them draw that triangle and then make a chart, ABC. We could look at several different things. One is you could have them prove Pythagorean theorem, because a lot of them by the time they're in geometry know that one. But one of the things that I do with it, when I label the A, B, C, and usually, of course, the hypotenuse being C, and I do this one being A, B, and C. And so I have them, a chart, do the ratio. Tell me the ratio of A to C. Tell me the ratio of B to C. Tell me the ratio of B to A. And you should know by now that's your trig functions, right? Or you could even do your special right triangles out of it. So I actually extend it first to look at your special right triangles of a 30-60. Look at the ratio and talk about comparing one to the other. And then I take it all the way into my sine, cosine, and tangent of a 30 and show them that, in fact, A over C is the cosine of a 30, and B over C is the sine of 30, and B over A is the tangent of it. But the thing that I find interesting to make it an inquiry lab is I have everybody draw their own triangle. And so I'll tell some of them to draw big ones and some of them to draw small ones. And I'll even tell the kids, draw more than one. Draw multiples of them. And we just collect a bunch of data. Okay? And that's the fun thing that I like, is letting them each do it, collect some data. That's really hard to get that sometimes right on 30. Or that, or I'm just real touchy. Okay. And so we do this with multiple ones. And some of that you can say, okay, that didn't work very well. But anyway, draw, multiple ones and get the measurements on there. Okay. And then just let them start again inquiring what kind of things what do they see? What patterns do they see? I don't bring in the special right triangles. I don't bring in trig functions and that until they start seeing a pattern saying, hey, this is always going to give me this number. Hey, this is always going to give me that number. So once they see the pattern, then I say, well, this is what it means. Look at your calculator. Look at, if I did the sine of 30, what value do I get? Hey, do you see a relationship there? And so forth. So that's what I do with Pythagorean theorem, special right triangles, so forth. And I think that activity is linked on the site also, that paper pencil part of it. Okay, I'm kind of hurrying through it so I don't have to make a lot of videos, but let's get, again, we'll go ahead and do a right triangle. On here, if you get your right triangle, whoops, I keep wanting to click when I shouldn't be clicking. There we go. And it doesn't want to move. There we go. Maybe. Anyway, so but here's the key, guys. You have to use the polygon shape. It has to be closed in. Click on it. These two will pop. Okay. Again, add label area. Tells you it's got an area of 8, and add perimeter, and it tells you it's 13.66. Okay, and so click again and add label. I would probably take that label off first so that they don't confuse it, because it does kind of blend the two together. So you could talk about area and perimeter. You could have them make their own problems, guys. Have them draw their own, okay? Draw your own rectangle or triangle and find its area. Okay, have them, okay, maybe it's this, okay, so then they're going to have to figure out how to find their height. Okay, so that's when I'm going to have to come in. Okay, I need to know the height. And so now we've got to have our tool here so that we can click on it and find the height. So we come over here, we add a label to that. Oh, okay, that's 2. Well, let's find this. So you don't even need to put the numbers on them. Make them create their own on that. And again, then when I would tell them to take off the label bit of it, but once they have their values that they need, and they calculate it on their own, then they hit the add label, and then there it is, and they can check to see if they're right. So again, kind of an inquiry lab. Let them try. Maybe you want to start with them counting squares, you know, a lot of different things there. Okay, area and perimeter. Okay, so again, I took just the line key and did dark lines to make a coordinate plane. And I'm going to go ahead, like what we did earlier, and I'm going to draw me a triangle. And so in this case, what we're going to go back to, if you want the kids to actually look at rules again. So we played earlier, now let's look at rules. So here is my triangle. And again, I wish, and maybe it's just me, I need to divvy more into it. I wish there was a way we could label these A, B, C again. So probably what I would do, again, is try to color them and see if that would help so that I have on that. But we're going to go on over to the transform. Okay, and I want to reflect this over the y-axis. So again, choose the line of reflection. There's my line. Choose my object and apply. And now we can talk about, again, looking at the points. Okay, looking at where they went. And again, I would make sure your kids don't draw an equilateral, don't draw a square. Be sure they draw something that is distinct, that they can look. Now, one of the things that's really cool about this is you can now move it, and they can actually see the relating parts, okay? Or if it's right on the line. Really cool, really, really cool, okay? So same thing you could do and reflect it if you wanted to over the on out. You could have it reflected about over the y-axis. You could do a y equals x-axis, y equals negative x, y equals x-axis, and so forth. Okay, so let's go ahead and real quick, I'm going to get rid of this one, and let's just go ahead and leave that one there, and let's go back to our transformations. And let's do a rotation. And so maybe what we want to do, we're going to take this point and, okay, and so let's do a rotation, okay? And so we're going to rotate it about this point, okay, this object, okay? And there it is, okay? Is that not cool? And again, same thing, you can play with it. And they can see that, and they can come up with rules. Okay? I think you can go in and change this to a 180. You can change this to a 270. Okay? And then, of course, anything else that you wanted to. But I just think that is, again, a very awesome exploration activity to do on that. Translation. Again, let's get rid of the rotation one. You're going to choose a point from, so I'm going, let's say from here, and where I want to go to. I'm going to move it to here. Whoops, in the object. Okay, and there's my translation. Again, same thing. Doop, doop. Awesome. Okay, so Desmos and exploration. Again, lots of things that you can do with it.